stuck on the top of a double black diamond. I can't get down this. SkiNav, can you help?
Of course we can.
My name is Brian Chen. I'm a first-year master's student at UC San Diego studying computer science.
Hi, my name is Troy. I'm a master's student in UC San Diego studying computer science.
Hey everyone, my name is Kyle Wade, and I'm currently a third-year computer engineering major. Welcome to SkiNav.
Well, you might ask, why couldn't users just use Google Maps to navigate? Unfortunately, Google Maps doesn't support that feature. In fact, skiers and snowboarders have to use a cluttered digital map which has lots of unnecessary information to navigate through the ski slope. Think about it. How many times have you been to a new resort, struggling to match a run on the map and trying to find which way to go at an intersection? You had to take your phone out of your pocket, take off your gloves because it's not touchscreen compatible, and you can't even enjoy your hands freezing outside for more than a second. SkiNav could help you. Once you set your starting point and ending point, SkiNav will find the optimal path for you and guide you with voice through your earbuds. So you will never need to pause the joy and say goodbye to freezing hands now and forever.
So, how does SkiNav work? You can think about every ski resort as a huge weighted directed graph, where nodes signify GPS coordinates and edges signify runs between GPS coordinates. Through labeling edges as either being an easy run, a medium run, a hard run, or a ski lift, we can have a complete map of any ski resort in the world. These edges also have weights to them, which signify the distance between two nodes. A higher distance equals a higher weighted value along that edge, which helps in our shortest path algorithm. To find the shortest path between any two nodes on a ski resort graph, we use a mathematically proven method in finding the shortest path in any arbitrary weighted directed graph, which is Dijkstra's algorithm. Using Dijkstra's, we can find the shortest path between any 2 points on a ski resort graph. Now, let's say we have a beginner skier, and this skier wants to find the shortest path from one point to another using only beginner runs. We can further improve upon our algorithm by finding the shortest path through only edges that are labeled as beginner runs and ski lifts. This ensures that the beginner only goes through the beginner runs. If a path cannot be found, we let the user know to update their filters to include more difficulties.
Now, let's introduce SkiNav API, the essential tool for your app. SkiNav API collects thousands of resort maps worldwide, storing them as directed graphs in its database. With SkiNav API, your app can effortlessly access a wide range of resort options and retrieve detailed map data for each specific resort.
Now, coming to the app itself. From the home page of SkiNav, the user can select the resort they are going to. After that, the app would request all the data of that resort from our database through our API. Once the app gets the data, it parses the data into 3 components, which are edges, nodes, and graph. For each edge, we record its edge type to see if it's a slope or a lift. Then we have the basic information of it, such as difficulty, names, the 2 endpoints of the edge, and last but not least, the status of the edge. For each node, we record its ID, coordinates, and its aliases for the user to search in the front end. To run the routing algorithm, we parse our data into a graph structure, which lists each node with all of its outgoing edges and pointed nodes. After selecting the resort, the app switches to the main page, and then the user could select their starting and ending points with the difficulty of the run they are willing to go. Once they press the start button, the algorithm will respond with an optimal route and show the route on the map. Then the user will be good to go. The app will navigate the user through the path with voice, and if the user gets off the designated route, the app will reroute a new path for the user.
Here is a basic demonstration of SkiNav using a graph at UCSD. We can see that the user selected to go from one part of UCSD to the other, and it calculates the fastest path for them to do so. When the user traverses along the path, we can see that the location updates, and it asks the user to go to the next part of the route. We can see that the lines here signify parts of the slope, and the pins signify the intersections between these slopes. When the user traverses to the nearest pin, it updates the location. In this case, when the user is finally at the last pin, and arrives, you can see that they have arrived at their destination.